Now we are going to discuss the sampling and monitoring devices that come with the system. First, we're going to show how to use the Casella microdust probe, which is the real-time optical device that monitors the aerosol concentration in the chamber. The monitor is equipped with a special device which is called a clear lens adapter. And what this is a special designed cuvette that makes sure that the aerosol flowing through it is flowing in a laminar mode, which means avoiding turbulence and avoiding the aerosol from basically being lost inside the probe. So we have two benefits. First of all, we have a more accurate measure of the aerosol. Second, it extends the life of the probe in terms of cleanliness, which means that we don't have to clean the lens so often because the probe has to be sent to the factory for in case it's dirty. In order to mount the clear lens adapter, which is going to come as a separate item with the probe, first of all, we have to remove the sleeve from the probe and put it into its case, not to lose it. Now you see, this is the hole where the aerosol stream sampling from the tower will come through, and the clear lens adapter makes sure that every single particle is going in a laminar way and is giving a light signal to the probe detector that is at the tip of the probe, so we have an accurate counting. In order to mount the clear lens adapter into the probe, we need to remove the fittings in order to remove the two parts of the cuvette inside. So remove the fittings on both sides. And remove the inlet and outlet. Now you'll notice that the diameter of the inlet part of the cuvette is slightly smaller than the outlet. And if you look in the bottom part of them, the words inlet for the inlet and outlet for the outlet are etched into them. So put the inlet and outlet down and slide the black block into the probe itself and align the holes of the block with the hole of the probe. After you did that, make sure that you're putting, you know which side of the cuvette are you putting in. Inlet on one side, outlet on the other side, and mount the 1/4 inch stainless steel tubing that ends up with the nose port adapter into the inlet side of the cuvette. So you have to make sure that you don't do it in the reverse order. And then on the outlet side, you put the other fitting that contains a filter to filter the aerosol that comes in, and the critical orifice is done, and the critical orifice that controls the flow through the cuvette. Tighten it up by hand. There's no need to use tool for that. And remove the plug from one of the ports that you reserved for sampling and plug in the device. Connect the data connector to the bottom of the probe. And connect the other end to the serial port of your computer or laptop. If you don't have a serial port, you can use an RS-232 to USB adapter to connect it with your computer. In the case there is the disk with the software of the MicroDOS Pro that you should install it before using the probe, and with the software you'll be able to run the measurements from the computer. You can also store the data that you measure from the system into the control unit and later on download the data into the laptop. Once we plug in the probe into the nose port, next step is to connect one of the sampling lines from the back of the panel with the device. It's a push to connect fitting, so you're just gonna hold it with one hand and push it in with the other until you hear the click. That means that the tube is held by the O-ring. Make sure that you can't pull it out. In all cases when we have push to connect fittings, in order to pull the tube out, you have to actually pull the ring that holds the tube, so the black ring that holds the tube, you have to push it towards the fitting, and that releases the tube from the grip. Again, tube in, and if you want to take it out, you just pull the ring back and pull the tube. Okay? Now, the outlet of the probe is equipped with a filter cartridge that filters all the aerosol that goes through the probe, and you can see it when visually you have to inspect it, and it starts getting darker. It means it's time to change it. The filter removes the aerosol from the stream and protect the critical orifice that is this gray thing that keeps the flow rate at a certain nominal flow rate when we pull vacuum with a pump. The choke has to be calibrated, and we show that how we do that with the flow meter, and so is the case for the chokes of the filter holder as well as the impactor. Once everything is in place, you can turn on the unit by clicking on the button with the vertical line, and it turns on, and it just takes few seconds to boot, and it starts reading right away. So at this moment, if we turn on the vacuum and the sampling line switch, you'll start seeing the reading, the real-time reading of the aerosol concentration. Now, the probe can be operated with the power supply on, which is recommended for extended periods of utilization, or it comes with 4 AA batteries that can be put inside the back of the unit, so it can be operated separately from the power supply. As I said, the software has to be installed in a laptop or PC computer, and the data can be observed directly onto the software. The manual is included with the package, or they can be read in the monitor of the control unit, stored logged into the data logger of the control unit, and at a later time downloaded to the computer. So it's your choice the way you want to operate it. The probe comes calibrated with Arizona road dust. So for any new powder or aerosol or liquid aerosol that you're going to use the system with, the probe needs to be calibrated for the specific aerosol, the scattering capabilities of the particular aerosol. So if Arizona road dust is calibration factor 1, different dusts or liquid aerosols will have a different scattering capability. The way that is done is to basically take a parallel sample of the real-time aerosol with a probe and a gravimetric sample with the 47mm filter. It's attached to another nose port that is left for sampling devices, and it has a choke that should be calibrated with a flow meter before the start of any sampling. It has a pre-filter that any particles that escape the filter are captured before going, not to affect the choke. So connect the second sampling line to the filter holder after you have loaded a 47mm filter, and start sampling at the same time. So use a timer, use a laboratory timer to measure the time, and let's say a 15 to 30 minute sampling period will be more than enough to have a good amount of aerosol on the filter. At the end, you will weigh the filter, you will calculate the concentration gravimetrically. We're going to give you a standard procedure for that. And in your computer, you will calculate the average of the readings of the probe, or you can read that directly from the screen, and then compare the two results. There is, on the menu in the probe, there is a way to enter different calibrations, different than Arizona road dust. The procedure is explained in detail in the manual of the Microdust Pro, how to do that. So when you use a certain aerosol, you always will select the factor that you determined by comparing the gravimetric method with the real-time method, and we'll use that one for a particular powder or liquid aerosol. For each new test article, you have to do this calibration of the probe. So then, when you choose the new calibration, you're going to know that the probe reads exactly the concentration that is in the chamber. The third sampling device that you are going to use is the multi-stage impactor, the Mercer impactor. It's made of 7 different stages that cut the aerosol from larger sizes down to the smaller ones. Depending on the flow rate, this impactor is rated for 0.5 liter per minute flow. You will have a certain you have certain cut sizes on each stage that come with the calibration certification of the impactor. The way you operate the impactor is exactly the same like the filter. Attach the impactor into one of the sampling ports. The impactor also has a calibrated choke, so every time you measure with the impactor you have to calibrate the flow rate of the choke, and it has a pre-filtering to protect the choke from any particles that escape the impactor. So the same way as with the real-time monitor, you just attach one of the sampling lines. Let's suppose you wanted to do at the same time a gravimetric sample as well as a size distribution sample of the aerosol. After you have calibrated the flow rates of the chokes and connected the sampling line, your vacuum pump is running. All it remains to do is, with your timer in hand, flip the switch on position on the panel and start measuring the time. When the time is up, let's say 15 minutes, 20 or 30 minutes, depending on what you choose, you just flip the switch off, and now you can remove your samplers for the processing, which is in both cases weighing with a microbalance. So you have to use a microbalance in order to have enough accuracy for the determination of your concentration. In the filter, holder case, you will open the filter by removing this blue ring and carefully remove the upper part. And on the support screen, you will have the filter that you put in when you started sampling. Now the filter has to be weighed and conditioned conditioned and weighed before being put on the sampler. And once again, you put it back, condition it again. It has to have exactly the same temperature and humidity in both cases before and after sampling. And the difference in weight, which is the weight acquired because of the aerosol deposition, will give you the concentration in the chamber. And this is provided with an SOP for the calculation of the concentration. And the same thing is after you finish sampling, disconnect the sampling lines and take the filter for the processing, and also the same thing, disconnect the sampling line. The same thing with the impactor. Remove it from the sampling port, plug the port, and then proceed with the procedure of weighing each of the stages. That procedure is outlined in the enclosed user's manual of the impactor. For any questions, we can always write specific SOPs for you. So these are the samplers. Now, to monitor the temperature and relative humidity in the chamber, this is the a relative humidity and temperature meter that is plugged directly into the nose port, which is the breathing zone of the animals. So plug in the adapter and simply turn on the unit and follow the procedure outlined in the user's manual to switch between different units, Celsius, Fahrenheit, relative humidity, temperature, and also dew point. And the meter comes also with a data cable. If you want to connect it to your computer, it's here on top. And you plug the serial port into your RS-232 on your computer, or if you don't have a COM port in your computer, you can use an RS-232 to USB adapter to use any USB ports in your computer. So you can download the data, or you can monitor in real time. You can read your relative humidity and temperature in your computer after you have installed the software which comes with the probe. So in case you want to read both the temperature and humidity as well as the real-time aerosol concentration from the probe, you can do it with the same computer with two RS-232 to USB adapters attached to it. So basically this was a summary of the sampling and monitoring devices that you are going to use with your system. The real-time aerosol probe, once you put in the clear lens adapter, there is no need to remove it again. You just stow it away safely somewhere. Make sure that you turn off the unit, disconnect it from your computer, your data cable, disconnect it from the power cord, and safely attach the unit into the probe and stow it away. If you have to do exposures with powders, the RBG, rotating brush generator, is the dust dispenser that you're going to use. It is relatively easy to switch from a liquid nebulizer to the RBG because all the connectors are compatible with the tower. We start by removing the Collison nebulizer. First of all, remove the air line going into the nebulizer, and the way it's done is click into this little metal tab, push it, and then the connector will come out, will just pop out. Loosen the screw until the Collison can slide out. Put the Collison away and take the adapter, the aerosol inlet adapter of the RBG that comes from its outlet at the back, and slide it in all the way in and tighten the screw. Now this is not a swivel, so the screw should be nice and tight to hold the adapter. Next, we are going to connect the control unit of the RBG to the deaggregator. There are two cables to be connected. It's this data cable. Click it in, and with a fine screwdriver, fasten the screws, and then the power cable that gives power from the control unit to the aggregator. Make sure that you put the pins in the right position. After the jack is in, screw in the jacket, tighten it up. The next step will be to connect the deaggregator to the compressed air source. The blue tubing comes with a special female quick disconnect that goes right into. Just push it in until you hear a click. This goes into a pressure regulator, and with a pressure gauge that reads the pressure, the RBG can stand up to 3 bars of pressure, and you can see the pressure here on the pressure gauge. And connect the other end of the tubing, the white tubing, to, as we mentioned before when we were talking about the filter for the compressed air, you're going to use, in case of RBG, directly one of the outlets of the manifold from the filter in here. So now one is going to feed the panel with clean air, and the other one is going to feed the RBG with clean dry air. Remove the plug and click the tube in. Make sure that it is all the way in.